So hey guys, we're going to start out today finishing up page 4 of our notes from the other day that we didn't get to, and then we're going to go ahead and go right into day 2 of rational functions. We're going to be dealing with points of discontinuity. So if you've got your notes already out, this graph represents, of course, the graph that is blank on your note page, and also this is number 6 that we need to work on. Now the key about number 6 is you can't do anything with this plus 1 the way it is, so we need to actually go ahead and add this together. This has been simplified too far for us, so the thing that we need to do is go ahead and get a common denominator. Well, the common denominator is going to be x plus 2. So I'm going to replace this 1 with x plus 2 over x plus 2. Now I can actually add them, so I have 1 plus x plus 2, which is just simply x plus 3 over x plus 2. Now we can go ahead and go through everything that we know. First off, our vertical asymptote. Set the denominator equal to 0, x plus 2 equals 0. So I have a vertical asymptote, x equals negative 2. So I'll draw that on my graph. Then I have a horizontal asymptote of 1. Hopefully you are picking up on that these are the same degree. 1 divided by 1 is 1. So the horizontal asymptote is going to be y equals 1. And again, these are equations, so please make sure that you give them to me as equations. Okay, so there's our horizontal and vertical asymptotes. We do have a 0. We take our numerator and set equal to 0. Well, x plus 3 is equal to 0, so I have a 0 at x equals negative 3. So here's a 0. And as far as a y-intercept goes, well, if I plug in 0 for both x both x, my y-intercept is going to be at the point 0, 3/2. Okay, so 0, 3/2 is up here. Okay, so now we need to get some more points. Okay, so I'm going to go ahead and do negative 3. So f of negative 3 is going to give me 0 over negative 1, or just plain old 0. Well, that makes sense because that's what we already had. That was silly of me to actually do f of negative 3. Let's do f of negative 4. So that's going to give me negative 1 over negative 2, or 1/2. So that brings me up here. Dang it. So you can hopefully clearly see that now our graph is going to go like this. Okay. Now let's do a couple points on the other side. Well, I've already got 0, so let's do f of 1. And that's going to equal 4 over 3, or 1 1/3. So this was 1 1/2, so 1 1/3 comes down to about there. Okay, and then let's do f of negative 1. So we get 2 over 1, or just plain old 2. So f of negative 1 is at 2, and this line is going to go like that. And there we have that function. So the biggest thing about this particular function is making sure that you get your common denominator and simplify the function back to something that's much easier for you to work with. Now, number 7, 8, and 9 are things that you're not going to see all that often. It's not stuff that I typically do, but I wanted to challenge some of you. So let's talk about it. We have a function And the function is in the form ax plus b over cx plus d. And this is on your notes, of course. Okay. We need to find a, b, c, and d, and the equation of a rational function that follows the following characteristics. Okay. So for number 7, we have a 0 at x equals negative 3. So that means that ax plus, if you put in, so if you have ax plus 3, or plus b, equals negative 3. I'm sorry. I'm actually going to start with the vertical asymptote. We know the vertical asymptote is x equals 2. Okay, so if x equals 2 for a vertical asymptote, that means that cx plus d had to equal 2. Okay, so that means that we have x equals negative 2 as an equation from our vertical asymptote, or x plus 2 equals 0. Okay, because remember, we're setting the denominator. So that would be my new denominator. So c would be 1, and d would equal to 2. Now, we have a horizontal asymptote of y equals 3. That means that the degree of the two x's have to be the same. So that means that a over c has to equal 3 over 1 in order to have a horizontal asymptote at y equals 3. So if c is already 1, then a has to be 3. Okay, so now we know that 3x plus b, okay, is our numerator. Okay, and we know that when x equals 0, we have when y equals 0, we have x equals negative 3. So what that tells us is we have something that says x equals negative 3. Well, but we know that a has to be 3, so let's multiply both of these by 3, so we get 3x equals negative 9. And then we have 3x plus 9 is equal to 0. So now our function is just simply 3x plus 9 over x plus 2. Now let's check ourselves before we wreck ourselves. Okay, the three things that we were given were that we had a vertical asymptote at x equals 2. Okay, so sorry, this should be x minus 2. Sorry about that, guys. We have a vertical asymptote at x equals 2. We move the 2 over to the other side, we get x minus 2. This gives us a vertical asymptote of x equals 2. We have a horizontal asymptote of 3. These degrees are the same. So 3 divided by 1 would be 3. And then we have a 0 at x equals negative 3. So if I put in negative 3 for x, negative 3 times 3 is negative 9. Negative 9 plus 9 is 0, so that is true. So this is our function, and our values for a, b, c, and d is 3, b equals 9, c equals 1, and d equals negative 2. Now I know that was pretty much clear as mud, let's go ahead on to number 8, and we'll go ahead and work on that one and see if that makes it a little bit more easier for you. Okay, so we don't have a 0. If we don't have a 0, that means it's not that it doesn't do what? It doesn't cross the x-axis. Okay, we have a y-intercept at the point 0, 2. We have a vertical asymptote at x equals -5. And we have a horizontal asymptote at y equals 0. Let's start with that vertical asymptote equation first. Okay, so if we have x equals -5, we're going to add 5 to both sides. And we now have x plus 5 equals 0. This has to be my denominator, x plus 5. Always start with the vertical asymptote. It makes life a lot easier. Okay. Now, if the horizontal asymptote is y equals 0, okay, so if I have a horizontal asymptote at y equals 0, that means the degree of the top is less than degree of the bottom. Well, right now the degree of our bottom is just 1, okay? So we need to find how we can get a degree of, or we have to have no degree at the top. So that means it's just some constant, right? Okay, so now we have our y-intercept. We have a y-intercept at 0, 2. So that tells me that if I plug in 0 to whatever my top is, so if I have ax plus b, if I plug in 0 for x, I'm going to get a y-intercept of 2. But keep in mind that I'm also dividing that by x plus 5. So that has to equal 2. Well, again, 0 for x, so I have b over 5, because 0 is going in for x, equals 2. Well, then what does b have to equal? B has to equal 10. So that means that a is going to equal 0, because it has to have a lower degree than the denominator. The denominator has degree 1, so that means that there can't be an x in the numerator. B is equal to 10, C is equal to 1, and D is equal to 5. So what's that going to give me? Well, that's going to give me 10 over x plus 5 for my function. And again, let's just check ourselves. All right, do we have a 0? Well, no, we don't have a 0 because, 10. If you plug in 0 on the top, it's not going to do anything. Okay. Do we have a y-intercept of 2? Yes, we did. We said if we put in 0 for x, we get 2 for y. Do we have a vertical asymptote of x equals -5? Well, yeah, x plus 5 equals 0, so -5. A horizontal asymptote of 0, well, yes, the degree is less than. So we did it. Okay. I know it's a little bit weird, but we did it. All right, so let's go on to number 9. Now for number 9, you were given a graph, and you need to come up with a, b, c, and d and the function. Okay. First off, find your asymptotes. There is a vertical asymptote at x equals 2. We have a horizontal asymptote of y equals 1. We have a y-intercept of 2. And we have a 0 at x equals 4. Okay, well, I always like to start with my vertical asymptote. So that means that if I have x equals 2, then I subtract the 2, so I get x minus 2 equals 0. So that means that the denominator of my function is going to be x minus 2. Okay, and that also means that c equals 1 and d equals -2. Now, if I like the fact that I have a horizontal asymptote of y equals 1. Because I have a horizontal asymptote of y equals 1, that means I have to have the same degree up top. Okay, so that means that I have to have x somewhere up top here too. Okay. Well, how can I get a y-intercept of 2? So if I put in 0 for x, and I have plus b. If I put in 0 for x, I have 0 plus b over negative 2 equals, and my y-intercept is 2. Okay? So if that's the case, negative 2 times, well, I have b over negative 2 equals 2. So b has to equal negative 4. So then that means that I should have a function of a equals 1 and b equals negative 4. So that means that I should have x minus 4 over x minus 2, and that should be my function. Now, do I get a 0 at positive 4 if I solve the numerator for my 0? Yes, I will. Okay, so I know this is really confusing, and but the more that you do them, the easier they will become. Okay. Okay, so everything that we've done so far have been continuous functions. Well, sometimes there are things called PODs, or points of discontinuity. Okay, if, for example, P of x and Q of x have a common factor, there's probably a point of discontinuity that's called a hole. Okay, so in order to find the y value of the hole, all you have to do is figure out what a is first, and then plug the value of a into the simplified function. Okay. The biggest thing here, we always said factor it. Okay. If you can factor it, factor it. So our first function is f of x is equal to x squared minus 4 over x squared minus 2x minus 8. So factor it. We have x minus 2, x plus 2, divided by x minus 4, and x plus 2. Amazingly enough, we actually have a common factor. We have the x plus 2, so we're going to cancel that out. Boom. Okay? So we're going to have x minus 2 over x minus 4. Okay. So remember, if we this is x minus a, so we have x minus 2. So we're looking for x equals 2. So we are going to plug in, x plus 2, because that was the factor that was common. So we're going to plug in negative 2. All right, so we're going to do negative 2 minus 2 over negative 2 minus 4. Negative 2 minus 2 is negative 4. Negative 2 minus 4 is negative 6. So we have a hole at the point negative 2, comma, 2/3. You always want to take the common one, okay, the common factor, and plug in and solve it. Pretend it was equal to 0, solve it for x, and get x equals negative 2. All right, and then we plug it back into and ignore the x plus 2 divided by x plus 2, and just solve it in the part that remains after you cancel out the common fraction. Okay, so the rest of it is still the same. We have a vertical asymptote at x equals 4. Okay. We're going to have a horizontal asymptote at y equals 1. We have degree 1 here. We have degree 1. We back up to the original. We have degree 1 and degree 1. Okay. We have a 0 at x equals 2. Okay. A y-intercept at 0, 1/2. Okay. So, what does this look like on our graph? Well, here's our vertical asymptote at 4. Here's our horizontal asymptote at 1. Okay. I know that I have a 0 at 2. So I have a 0 right here. A point there. And I also know that I have a hole at -2, 2/3. So here I want to draw a nice little circle with an open hole in it. That was not good. Okay. There we go. All right, so I'm going to leave it up to you guys to know that you can plot more points, and it's going to go down like this. Okay. Notice that we have a hole here at the point that we found at -2, 2/3. That's a discontinuity. And then over on the other side, it's going to look something like that. And again, I would leave it up to you to find those points at this point. The main point that I'm looking for today is that you can find the discontinuity point. So let's do another one. All right, we have f of x equals x cubed minus 2x squared over x squared plus x minus 6. Again, factor it. So I have x squared times x minus 2 over x plus 3 times x minus 2. All right, so the x minus 2 is what I'm looking at. Okay. So I set that equal to 0. X minus 2 equals 0, so x equals 2. So the x value is going to be 2, and I'm going to plug that back in. And this is my hole because I have a common factor. The x value of my hole is 2. I'm going to plug it back into the original function that's already been factored, so I'm going to have 2 squared over 2 plus 3, which gives me 4 over 5. So I have a hole at the point 2, 4 fifths. Okay. Vertical asymptote is going to be at x equals -3. I am going to have a slant asymptote. And how do I find that? Well, I do my -3, and I have 1, 0, 0, because it's 1x squared plus 0x plus 0. So I bring down the 1. That becomes -3, -3. This becomes 9. That's going to be 9. We don't care about that. So we have x minus 3. So my slant asymptote is going to be at x, or y equals x minus 3. Okay. I'm going to have a 0 at x equals 0, and it's got a multiplicity of 2. Because remember, x squared equals 0, so you got x equals plus or minus 0 as a reminder. And of course, I've got a y-intercept at 0, 0. Because 0 divided by 3 is still 0. Okay. I'm going to leave that one up to you to graph. Again, the main point of today is finding these discontinuity points. Okay. Okay, let's look at the third function. X squared minus 4x minus 5 divided by x minus 1 squared times x minus 5. All right, so let's factor. We've got x minus 5 times x plus 1 over, I'm just going to write it backwards so you can see, x minus 5 times x minus 1 squared. All right, so our point of discontinuity, the x value, is going to be 5. My y value for the discontinuity is going to be 6 over 4 squared, which is going to be 6 over 16, which is 3/8. So we have a hole at 5, 3/8. Now, vertical asymptote. Well, x minus 1 squared equals 0. I have it at x equals 1. So basically what that tells me is that this is a double asymptote. And that really doesn't mean a whole lot. It would help you if you knew what it meant as far as graphing goes. You really don't have to worry about it that much. Okay. Your horizontal asymptote. Well, the degree of the top is less than the degree of the bottom, so it's got to be y equals 0. Okay. We do have a 0 at x equals -1. Okay, and we do have a y-intercept of 1. 0, 1. Again, plug in the 0 and solve it. Okay. And again, I'm going to leave that up to you all to graph. Okay. 4, 5, and 6 is looking at the graph and seeing if you can come up with which one of the ones makes the most sense. So we're going to do that in a couple minutes, or a couple seconds here. Okay, so for number 4, start with your vertical asymptotes, guys. You have vertical asymptotes at 2 and -3. Okay, so that means that you have x minus 2 and x plus 3 in the denominator. Okay, so if that's the case, that eliminates a and, well, it eliminates a for sure. Okay, now look at your choices here. For letter B, that tells me, that says x plus 1 squared. Okay, or is that cubed? Sorry, that says x plus 1 cubed. And the degree of the denominator is x squared. So that means that I would have to have a slant asymptote. There is no slant asymptote, so we're going to eliminate b. Now, in order to have a horizontal asymptote at 1, that means that the leading coefficients have to be the same, and it has to be the same degree. So if you look at letter C, you do not have a horizontal asymptote. Okay. You have two. You would have a horizontal asymptote at 0 because the degree of the top is only 2. The degree of the bottom would be 4. So the horizontal asymptote does not equal 0. So in D you have the same degree, at the top of 2, and the bottom has a degree of 2, and the leading coefficients will be 1. So that would give you a horizontal asymptote at 1. So the correct answer for number 4 would be D. Okay, for number 5, again you have a vertical asymptote at 1. Okay, well that doesn't help much because you can't get rid of anything. Okay. Now you have a horizontal asymptote at 1 as well. Okay, so what does that get rid of for us? Okay, so as far as number 5 goes, the key here is looking at the degrees of the x's, or the numerator and the denominator. You know, because it's not labeled, that you have a horizontal asymptote, but it's definitely not at 0. Okay, so that means that the degree has to be the exact same on the top as it is in the bottom. And if you go through, the degree of the numerator for letter A is 1 plus 2 plus 2, which is 5. The degree of the denominator is just 4. So they are not the same, so it can't be A. If you look at C, 2 plus 1 plus 2 is 5 over 4. Again, not the same. B has 1 plus 2, which is 4 over 4. Hey, there we go. D has 1 plus 2, which is 4 over 3. So for number 5, the only one that it could be is letter B, because it's the only one that has a horizontal asymptote not at 0. The others either have one at 0 or a slant asymptote. Okay, so for number 6, you have asymptotes at -2 and +4. Well, that's not very helpful as far as the pictures go, because if you look at the denominators for everything, it's still possible. But you also have a you know that you have a horizontal asymptote at 0, so that means that the degree of the top has to be less than the degree of the bottom. You also don't have a 0, so that eliminates A, because you would have a 0 at 0 for that particular one. So that leaves C, or B, C, and E. B, C, and D. Well, trying to get this done in a hurry. Sorry, guys. So what do we have? The degree of the top looks pretty good for all of them. I mean, none of them have any degree. The bottom, that we definitely would have a horizontal asymptote at 0. So where are we? How can we figure out the rest? Well, the only thing that we haven't checked was be the y-intercept. Well, we don't know exactly what the y-intercept is because it's not mentioned or marked or labeled, but we do know that it's a negative number. So, how do we do this? Well, if we put in 0 for x in B, we get -4 times 2, which is a negative number, and then you have a negative divided by a negative, which would give you a positive. Notice at D, we also, that would be a negative squared, or -4 squared, which would be 16. times 16. So that would give you like negative 3 something really small. Okay, so that would give you a negative. And then you have negative 3 over, if you're looking at C, you have negative 3 over 16 times 2, which is 32. So, it's got to be either C or D. And honestly, guys, the only way that you're really going to see this is just by scale. And so the correct answer for number 6 is C. But hopefully that makes sense to you. Hopefully you can find those points of discontinuity and, then determine what's the best. So you guys have a great day, and I will see you tomorrow morning.